my dear students. In today's class, let us learn about the third chapter of the 10th standard, that is metals and non-metals. So in this metals and non-metals, you are going to study the physical properties, chemical properties, activity series and the extraction of the metals. So all these points has been covered in this lesson. So let us see. In the beginning, they have given about the physical properties of the metals and non-metals. Let us see metals and non-metals. Okay, so here which are the physical properties of metals and non-metals, I will say. So metals, in your notebook also you can divide into two parts. In one part you write metals and another part you write non-metals, so that it will be easy for you to study, because here and there they have given the properties in the textbook. So all together at a time I have concluded here. So which are the properties? See, some 8 properties are there here. So which is very easy also. You can write it in the sentence, but I have written in the word. Okay. The first property is the lustrous property. Lustrous. That means metals are having lustrous property. That means it is having the shining surface. For example, gold, silver, iron. If you see some of the metals, you have to rub it and see. Then you will see the property of the luster. That means having the shining surface. Lustrous means it is having the shining surface. So all metals are lustrous in nature, or they have the property of lustrous. They have the lustrous property, you can say. Metals are lustrous in nature. And come to the part of the non-metals, they are non-lustrous. So some exceptional cases are there. So which are the exceptional cases I have written separately, so that it will be easy for you to study. Either in the physical or chemical property they ask you one question, or in the exceptional cases they will ask one question. It is compulsorily they may ask either here or here. That's why you have to study properly. At a time you will get here and there they have mixed in the textbook, but I have written all together at a time. So you can copy down this in a sheet or in the notebook, so that it will be easy for you to study. So the first property is the lustrous property. All metals are lustrous in nature and the non-metals are not lustrous. They are non-lustrous. You write it in the sentence while writing in the notes. So in the nature, the metals are hard. Metals are hard. Non-metals are soft. They are hard. They are soft. Then come to the malleability and ductility. All the metals are having the malleability and ductility property. What do you mean by malleable and ductile? Means when you beaten this metal, or you can draw into wires, or you can beaten into sheets. So all the metals can be drawn into wires, or you can beaten into sheets. That property of the metals are known as malleability and ductility. You can draw into wires, ductility property. So that's why, because of having this property and also the lustrous property, they are used in the ornaments. For example, gold, silver, all these are used in the ornaments. Why they are using in the ornaments? They have the property of lustrous first. It is having the shining surface. That's why they use in the ornament metals. Which metals are used in the ornaments? Silver and gold. So why gold and silver are used as ornaments? If they ask the question, these 3 properties you can tell. The first most important property is lustrous property, and also it will not react with the air. That's why it is used. So here malleability and ductility. It can be drawn into wires. 1 gram of the gold can be drawn into the long lengthy wire till 1 kilometers. That much length they can able to drawn. That's why this ductility, because of the malleability and ductility property, they can give shapes to the ornaments. Then come to the sonorous. Sonorous means, see here, making sound. That means the metals are hard, and when you touch with the other metal, it makes sound. In schools, school bells, they use the metals to ring the bell. Why they use the metals to ring the bell? Because it is having the sonorous property. That also they may ask the question. Why they will use the metals to ring the bell? Because it is having the property. Which property suits them? The sonorous property. Sonorous is nothing but making sound on touching with the other hard substance. When the metal touch with the other hard substance, it makes sound. See here, it is not making sound. But when you take the iron and another hard metal, if you take and if you beat like this, you will get the sound. That property is known as sonorous. All the metals have sonorous property, but the non-metals are non-sonorous. Non-metals are non-sonorous. I have not written all the points to the non-metals. So that here lustrous, non-lustrous, hard, soft, malleable and ductile, not have the property of malleability, not have the property of the ductility. Sonorous, it is not sonorous. Good conductor of heat. All the metals are good conductor of heat. Some exceptional cases are there. I will talk here. So all metals are good conductor of heat. They conduct the electricity. Here they have given some experiment over here. In a textbook they have given the experiment. Many kind of experiment you can conduct. See here, you take the iron rod. You take the iron rod and heat it in one side. Heat here. This side you heat and touch here. What will happen? It will also get some. That means your hand will get some heat. That means what happens when you give the heat here? That heat transfers slowly to this end. That's why it is called as good conductor of heat. Then come to the electricity. In our home, for conducting the electricity, we use the copper, which is a metal. So all the metals are good conductor of electricity. It is having the property of conducting electricity. That's why they are good conductor of electricity, good conductor of heat. Here also they have given one experiment. Take the cell, then pass the current. Here you can use some iron piece. You can use the iron rod. So here you can use the bulb also. So through this iron rod, it conducts electricity, or the copper wire. You can take the copper wire, or silver. Silver is the best conductor of electricity. The best conductor of electricity, first comes silver, then comes copper. But we are not using the silver everywhere. You know, the economically it is very it costs silver, and also robbers may rob that silver in the night. That's why we use instead. Though the silver is having more ability to conduct the electricity than copper, we are using what? Copper rather than silver due to the due to economic condition. So here copper or silver rod you take and conduct the electricity, the bulb starts glowing. That means this experiment indicates that it conducts electricity. So for good conductor of heat and good conductor of electricity, they have given experiment in the textbook. You can see there. And high melting point. It is having high melting point. What do you mean by melting point? Means, see here, you take the candle pieces or camphor. You take the camphor or the candle pieces. Here you take the iron rod. Start heating. Directly you can take in the spatula. You take in the spatula, you take iron fillings. Iron fillings you take. Here camphor you take. Start heating. So it melts. Camphor will melt very soon. But here iron fillings will not melt. You have to give more and more heat. So to melt this, it requires high heat, high amount of the heat. That's why it is having high melting point. To melt that particular substance, it requires more heat. So if it requires more heat, high melting point. If it requires less heat, it is called as less melting point. So camphor is having a less melting point, or this candle also. The candle pieces, if you take it will melt very soon. So very low melting point it is having. But here the metals are having high melting point. Okay. So high melting point. So these are the properties of metals. But here they are poor conductor of electricity. They are poor conductor of heat. That does not conduct the electricity. You can say that does not conduct the electricity. They do not pass the heat through the through non-metals, and also they have low melting point. Then come to the next point. So these are the differences between the physical metals and non-metals, which is a physical property. So they can ask anything. The meaning of lustrous or the meaning of sonorous, they may ask what is malleable, malleability, or what is ductility, what is lustrous, what is sonorous. So like that also they may ask the question, or they may ask the difference between the metals and non-metals, or the physical properties of metals they ask, or the chemical properties of the metals they ask, or why the metals are used in school bells. So that type, because on which property based they are used in the school bells they may ask. Sonorous property you have to write. Why they are used in the ornaments? Because they are lustrous in nature. That property you have to write. So other properties you also, if they ask malleable and ductile also you can write. So pertaining to and also copper wire is used to conduct the electricity. Or copper is used as a metal to conduct the electricity. Why? If they ask, it is a good conductor of electricity, that's why used. So like this they will ask different types of questions in this, you can learn. So write it in the notes and learn it. It will be very easily you can learn, because in the textbook here and there they have mixed the properties. Here altogether at the time you will get. Then coming to the part of the non-metals, it produces acidic oxides when dissolved in water. Non-metals, when dissolved in water, it produces acidic oxides. You have to see acidic oxides it produces. When the metals reacts with are dissolved in the water, it produces basic oxides. But here non-metals, acidic oxides. You remember that point also. So acidic oxides on dissolving with water gives non-metals produces acidic oxides when dissolved in water. That point you have to remember. And here two experiments they have given for good conductor of heat and good conductor of electricity. Now come to the part of the exceptional cases, which is more important, and one question they may ask. Which are the exceptional cases? Let us see. Exceptional cases is nothing but, we have already told, all metals are lustrous. But all metals are hard, all metals are malleable, all metals. Here non-metals, no, it is not lustrous, like that it is there. But some exceptional cases is there. All non-metals are non-lustrous except something, or all non-metals metals are hard, solid in nature, but it occurs in one metal occur in liquid, which is a metal. For example, here I will explain that. So let us see. So which are exceptional cases, like that only, under this heading only if you write, it will be well and good, you won't forget. So here I have written all the exceptional cases of the metals. Here I have written all the exceptional cases of the non-metals. So see here, soft metals or alkali metal. Give examples for soft metal or alkali metals. Already I told the metals are hard. All metals are hard except sodium, lithium and potassium. So some of the metals are soft in nature. You can cut it with the knife only. Suppose for example sodium, if you take with the help of the knife only you can cut. But metals we cannot cut with the knife. That means some of the metals are soft. Not all the metals, only few metals are soft. Which are those metals? If they ask sodium, lithium, potassium, you have to remember. And which are also called as the alkali metals, because it dissolves in water. Then soft metal. First one, the soft metal. Give examples for soft metal or alkali metal: sodium, lithium, potassium. Write down first one. Then the second one is a high lustrous property of the metal. All the metals are having a high lustrous property, but lustrous property it is having, but highly lustrous means gold and silver. Because of having the high lustrous property, they are used in the ornaments. So see, if you compare the iron with the gold, iron is not having that much of lustrous property. That's why here high lustrous property of the metal means gold and silver, you can write. Next, good conductor of heat. Which is the metal which is a good, very good conductor of heat, the best conductor of the heat ಅಂತ ಹೇಳ್ತಾರೆ. So you can write silver or copper. You can give the example of silver or copper. Then good conductor of poor conductor of heat. They have given here is poor conductor. Here good conductor. Good conductor comes under silver and copper. Poor conductor, you have to remember, this is very important, lead and so for he This is for electricity. Wait, this is for electricity. Written wrong. Electricity. Good conductor of electricity, silver and copper. The best conductor, actually the best conductor of the electricity is silver, but we are not using, I told already. The silver is very costly, that's why instead of, though it is the best conductor of the electricity, so electricity, you make it as electricity. So the best conductor of the electricity is silver, though it is the best conductor, we are not using that because it is a costly and also robbers may rob that. So copper. The next comes copper. They are the best conductors of electricity. Give examples for the best conductor of electricity, silver, copper. Then poor conductor of heat. They have asked about a heat. Poor conductor, lead and silver. Conduction of heat here. So poor conductor of heat, lead and silver. Then come to the liquid metal. Already I told all the metals are solid in nature. So you can say almost all the metals are solid in nature, but except one metal which is a liquid in nature. So give example for the metal which occurs in the liquid form. They may ask like that type of the question. So give example for the liquid metal. Or liquid metal is an example for the liquid metal is dash. They will ask. So mercury, you have to remember mercury. Liquid. Mercury is the liquid metal, not the non-metal. You have to remember, I am talking only about the metals. Here I am talking only about the metals. Here liquid metal. Liquid metal is mercury. So M, you can remember mercury, MM. And also metals have less boiling point. Here I told a high melting point and high boiling point. All the metals are having high melting point and all metals are having high boiling point except except two metals, that is gallium and cesium. Gallium and cesium is having low boiling point. Which are the metals which are having low boiling point? All the metals are having high melting point, high boiling point, but two metals which are having less boiling point, that is gallium and cesium. These are the exceptional cases. So they will ask these exceptional cases in the exam. You have to remember this. Then come to the next one, non-metals. Which are the exceptional cases of non-metals? I told you here liquid non-metal. Liquid metal is different from liquid non-metal. Liquid metal is mercury. See, liquid metal is mercury. Liquid non-metal is, you will get confused. That's why separately you have to write and learn. So liquid non-metal is bromine. Liquid non-metal is bromine. And lustrous non-metal, I told all the non-metals are non-lustrous. All the non-metals here, all the non-metals are pertaining to this non-lustrous except what? Iodine. Iodine is a lustrous non-metal. Only iodine is having the property of lustrous. That means it shines. Iodine is having the shining surface, but it is a non-metal. Bromine occurs in the liquid form, so the liquid non-metal is bromine. Then non-metals occurs in different forms. Different forms are the allotropic forms. Here also I have written allotropic forms of the carbon. Give examples for the allotropic forms of the carbon, or which are the different forms of carbon. Which are the substance that occurs in different forms of carbon. Allotropes of carbon they may ask, or different forms of carbon. Write the different forms of carbon if they ask. You have to give example: diamond, graphite, charcoal and coal. That means carbon occurs in different form. That means in the diamond carbon is there. Carbon is there in the form of diamond. Carbon is there in the form of graphite. Carbon is there in the form of charcoal. Carbon occurs in the form of coal. So these are the allotropes of carbon, or the different forms of carbon. So write the allotropes of carbon. If they ask, you can write. What is allotropy? Allotropy is nothing but the carbon occurs in different forms. The different forms of carbon is called allotropes. Okay. Next come to the next one. So the non-metals occur in different forms. Carbon, example. Which is the non-metal which occurs in different form? Example, if they ask, carbon you can give. Then non-metal which conduct electricity. See, all the non-metals will not conduct electricity except one non-metal, that is graphite. You remember graphite in the pencil, lead. Pencil, in pencil you can see the lead, no? That is called as graphite. So which conduct electricity. So graphite is the only non-metal which conduct electricity. So these are the exceptional cases you have to remember. Write down the exceptional cases separately, write down the physical properties separately, and learn very easily. You can write and learn. Like this, one by one only if you write, you can learn better. So okay, now come to the next one, sodium. About the sodium metal they have given important one. Why sodium metal is kept under kerosene? See here, it is a piece of the sodium. So here is the environment. So here in the room, I have kept on the table. I have kept it on the table. So I have kept this sodium on the table. After sometimes it loses its lustrous nature. I told already it is having the lustrous property because it is a metal, soft metal, sodium. So sodium, what will happen? It will loses its lustrous property. And if the moisture is there in the air, it reacts with the moisture of the air and releases hydrogen gas. Or some drops of the water, if it falls on this sodium, it catches fire because it reacts vigorously with the water and catches fire. That's why to avoid the reaction with water or air, it is kept under kerosene. Why do you keep sodium in the kerosene if they ask? Why sodium is kept under kerosene? Give reason if they ask. Sodium is a highly reactive metal. First point is sodium is a highly reactive metal. If we won't keep in the kerosene, if we keep in the environment, it reacts with the air or moisture content in the air, and it may catches the fire or it may lose its lustrous property. That's why, and the layer it becomes oxide. Sodium becomes sodium oxide. That's why because of its high reactivity capacity, it is kept under kerosene. So that is very important that you have to learn. Next, come to the next this thing, very important. All these points are important. One by one you have to learn like this. Amphoteric oxides. What are amphoteric oxides? And give examples they ask in the exam. What are amphoteric? In the question paper also you can see this type of the question. Amphoteric oxides. Give example for amphoteric oxides. Some of the metallic oxides. What is amphoteric oxide? Some of the metal oxides which reacts both with the acid and with the bases. Usually all the metal oxides reacts either with the acids or with the bases. But here some oxides, for example aluminium oxide and the zinc oxide. So two example, you can give example for amphoteric oxide means aluminium oxide and zinc oxide. So some of the metal oxides, for example aluminium oxide and zinc oxide, reacts both with acids and the bases. That kind of nature is there to these oxides, and the property of having reaction with both the acid and the bases, that is called as amphoteric oxides. The metallic oxides which reacts both with the acid and the bases are called amphoteric oxides. Example Al2O3ZNO. It is there in the textbook, you can learn. So very important, amphoteric oxides. And also why sodium is kept under kerosene. And also exceptional cases. 6 exceptional cases are there in the metals and 5 exceptional cases are there altogether at a time written. And also physical properties of